Okay, tonight your notes are on the moon and seasons. Let's see if I can navigate. Here we go. Okay, first of all, you need to know about the formation of the moon. Basically, this picture says it all. The Earth had already been formed, an Mars-sized object hit the Earth, it blasted part of the crust and mantle out into space. The debris floated around, revolved around Earth for a while. Eventually, it joined together and cooled. When it joined together and cooled, voila, there we have our moon. Don't worry about the video, just ignore it. Okay, you need what is in yellow. First of all, our moon is only a quarter of the size of the Earth, and the gravity is 1/6 that of the Earth. Daytime on the moon is really hot, 273 degrees Fahrenheit, and nighttime is very, very cold, negative 244 degrees Fahrenheit. The moon is tectonically active. It has moonquakes, about 3,000 of them or so a year. The oldest rocks on the moon date back 4.6 billion years. That is the proof that we believe that states that it formed the same time or roughly the same time Earth did. Where is my mouse? There it is. Okay, here are some pictures of the moon. The largest crater is Copernicus. That's the very edge of it. Here it is from the side. You can look up at the nighttime sky and you can see the moon. But when you're on the moon, this is what Earth looks like. Okay, and this is the far side of the moon. The far side of the moon we never see. Okay, to us it's always the dark side. It has a lot more craters than the light side that we see. This is literally a picture of it taken with the super bright light. Okay, the moon has several features you need to know. The highlands are mountains. It's literally land that is high. They can soar thousands of meters into the sky, and they actually appear as the light areas we see on the moon. So when you look at the moon and you see the light areas, those are the highlands. Okay, there are valleys that cross most of the surface, and it might be proof that there was volcanic activity on the moon. It's thought that those are leftover channels left from lava, like literally channels that the lava flowed in. Those long valleys are called rills. And then the dark areas of the moon. So when you look up at the moon and the dark areas you see, that is solidified lava. Magma that came out, it cooled, it's now like literally dark colored. These are the flat plains. Okay, so the mountains are the highlands, the valleys are rills, and the flat plains are the Moria. I might be pronouncing that wrong. And the only reason they're dark is because they reflect less light. Okay, there are depressions, craters on the moon. Those are literally from leftover debris in the solar system that has struck the moon. If you're looking at this crater here, you're going to see like these white lines coming out from it. Those white lines or light colored lines are called rays, and they extend out from the impact area. The lunar surface is covered with crust rock and dust, and it has a name called regolith. Okay, I know my picture is in the way, but it's R-E-G-O-L-I-T-H. And the depth is anywhere from 1 to 6 meters deep. Kind of think of it like ashes from a fireplace. It's sort of like that, but a little more dense, a little more heavy. Okay, the moon. When it revolves around the Earth, there's points when the moon is closer to the Earth and points when it's farthest or farther away from the Earth. Okay, when the moon is farther from the Earth, it's called apogee. A for away, it's farther away from the Earth. And if you look at this picture here, when the moon appears to be smaller in size, you know that's when the moon is in apogee or farther away. When the moon is close to the Earth and it looks bigger like this, you know the moon is at perigee. So A away and perigee, I don't have anything clever for that. It's just closer. If you ever hear of a harvest moon, that's when the moon is at its closest point to the Earth in its orbit, and that's perigee. The very first picture in the slideshow was the moon at perigee. Okay, so why is a harvest moon orange? The moon looks orange during usually the autumn time because we're looking at the moon through 2 times as much atmosphere, and it looks huge because of, once again, perigee. When the moon's directly above us, there's not that much atmosphere between us and our view. But you kind of have a 90-ish degree angle when the moon is at perigee, and you're looking through more of the atmosphere, which is refracting the light as the light's coming through. Okay, and it gives that giant moon that's at perigee, it gives it that orange look. Okay, the moon rotates and revolves at the same exact rate. That's why we only see the same side of the moon. 12 men have walked on the moon. The first two were Neil Armstrong and Buzz Aldrin. I don't know what happened. Okay. They were in the lunar module named Eagle as part of the Apollo 11 mission. Lunar module Eagle, Apollo 11 mission. Super important thing to know here. This has shown up on your SOL many, many times. So put a star next to it. Okay, here's some pictures about the different Apollo missions. Go ahead and take a look at them. I'm moving on. Okay, moon phases. Generally, when I teach you moon phases, I start at where do I start? I start at the new moon phase. Okay. Now, when you're looking at moon phases, okay, I always start the new moon. After you get at the new moon, which is like completely dark, you don't see it at all, you start to wax. Waxing means growing, or you have your light on the right. So you start with a waxing crescent. The first quarter, a waxing gibbous, and notice the light is on the right in the waxing phase. Then the full moon, which we can see. Okay. After the full moon, it starts to wane away, or the light starts to disappear. Okay, so light is leaving the left. That's what I think for waning, leaving the left. Okay, you get the waning gibbous, the last quarter, and the waning crescent, and then you get your new moon. Eclipses. Okay, first of all, if you just draw a picture of this, you're pretty much good to go. A solar eclipse happens when the moon moves into position so that it blocks light from the sun to the earth. For us, it appears to go in front of the sun. And I have, remember, SME, sun, moon, earth. If you draw this picture right here, and it doesn't have to be totally colored or anything like that, just sketch it out and label it. That's all you really need. Okay, you do need to know that during a solar eclipse, you can see the outer layers of the sun. Okay, so draw the sun, put an S, draw a little moon. Remember, it's a quarter of the size of the earth. So put a little M, draw an earth, put an E. And then we have the umbra and penumbra. You're going to see the sun's light hits the moon, and then it kind of bounces off, it reflects off the moon, and it hits the earth in this teeny little area here. This is called the umbra, and this is where you can see the entire eclipse. If you're in the shadowed area, that's called the penumbra with a P, and you see a partial eclipse. And if you're not in the umbra or penumbra over here somewhere, you don't see the eclipse. Okay, that's what a total solar eclipse looks like. We're actually going to replicate eclipses and moon phases in class. So you don't really need much down here. Just take a look at them. They're pretty. And then a lunar eclipse, once again, we have our picture here, okay, is when the Earth moves into position so it blocks sunlight to the moon. I remember it as Luna last. The lunar eclipse, Luna comes last. The moon comes last. And the moon, some people call it a blood moon. It kind of gets this reddish, kind of rusty color to it. Okay, so lunar eclipse, sun, Earth, and the moon is last, Luna last. And once again, you have an umbra, which is much bigger. So a lot more of the Earth can see the eclipse, the lunar eclipse. And then we have our penumbra, or partial eclipse over here. Okay, we have those already if you want to copy them, but go ahead, but you should have gotten them already. Okay, eclipses can happen up to 7 times per year, but the moon's orbit lies outside of Earth's orbital plane, so total eclipses occur infrequently. Okay, if you look at this picture here, the moon's path is here. It's in gray. Okay, and the way we revolve around the sun is sort of in yellow here. You only have an eclipse where the two lines intersect. There's another one down here and then right here. That's the only time you have an eclipse, when everybody is on the same ecliptic plane or orbital plane. Okay, this you don't need to know. It's just interesting. Go ahead and take a minute and read it. Okay, tides. And we're almost done. Tides are the rise and fall of the oceans due to the moon's gravitational pull on Earth. You have a spring tide, which is when the moon is in the full or new phase. The high tides are very high and the low tides are very low. Neap tides occur when the moon is in the quarter phases, and you don't have much of a difference between the high and the low tide line. Don't worry about this. You're going to be doing this in class anyway, so just ignore it. And the seasons. We're almost done, folks, I swear. Okay, reason for the seasons. The Earth is tilted at 23.5 degrees. So when you're tilted toward the sun, it is summer, and when you're tilted away, you have winter. It is not, N-O-T, not the Earth's distance from the sun that affects the seasons. It is the tilt of the Earth. Okay, we have two other words, aphelion and perihelion. As the Earth revolves around the sun, there are times in our revolution when we are closer to the sun and farther away. If we are away from the sun, it is called aphelion. Once again, A, away. So the Earth is farther from the sun. If we are closer to the sun, we are at what's called perihelion. Don't worry about these. We're going to do these in class, so skip these. There's Earth in each season, and you are done. Okay, have a good night, folks.